So hello dear students, welcome to my channel. Today we will study about Lorentz transformations. Most important question, Lorentz transformations. So in the previous lecture we have studied about Galilean transformation equations and the applications of Galilean transformation equations. There is a difference between Galilean and Lorentz transformation equations. In Galilean transformation equations, the frame of reference is moving with a speed which is very smaller than speed of light. But if the frame of reference is moving with respect to the other frame comparable to speed of light, then Galilean transformation equations are not valid. We need new transformation equations called Lorentz transformation equations. So here we deal with inertial frames of references. We have two frames. One is S frame, whose origin is O. This is S frame. Another is S dash frame. So the origins of both the frames, they coincide at t is equal to 0. But the second frame is moving with velocity v along the positive x-axis. So at any time, the situation will be like this. The two frames, they will be depicted like this. This is the first frame. This is the origin, S frame, and S dash frame. It will be moved a little bit along the positive x-axis as it is moving with velocity v. So this is the situation at any time t. Here velocity is comparable to speed of light. So this is the major difference between Lorentz transformation equations and Galilean transformation equations. Again, Lorentz transformation equations में velocity comparable to speed of light होती है और Galilean transformation equations में velocity negligible होती है जिसको हम इग्नोर कर सकते हैं, very small as compared to speed of light. तो हम सपोज करते हैं कि ओरिजिन पे there is a source of light. तो जो source of light है, it is a point source. So it will be emitting light in all directions. The secondary wavelets emitted by this source, it will give us a spherical wavefront. So at any time t with respect to origin O, the spherical wavefront will grow like this. And with respect to origin O dash, it will grow like this. So these are the two scenarios. In both the frame of references, we will be seeing the spherical wavefront. दोनों फ्रेम ऑफ रेफरेंस से हमें स्फेरिकल वेव फ्रंट मिलेगा. एस फ्रेम से उस स्फेरिकल वेव फ्रंट का ओरिजिन ओ होगा. एस डैश फ्रेम से उस स्फेरिकल वेव फ्रंट का ओरिजिन ओ डैश होगा. तो इफ वी टेक अ पॉइंट पी इन एस फ्रेम on the spherical wavefront having coordinates x, y and z and join OP. So OP is the distance traveled by लाइट, क्यों, जो हमने लाइट सोर्स रखा है पॉइंट ओ पे, तो जब वेव फ्रंट ग्रो करेगा स्फेरिकल वेव फ्रंट की फॉर्म में, तो वेवलेट्स ओ से पी तक पहुंचेगी, तो उसकी जो स्पीड है दैट विल बी इक्वल टू स्पीड ऑफ लाइट, एंड दिस सिचुएशन इज एट एनी टाइम टी, तो ओपी डिस्टेंस की वैल्यू सी टी होगी। सो डिस्टेंस फॉर्मूला लगाकर हम ओपी को लिख सकते हैं एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर, इट इज इक्वल टू सी टी स्क्वायर। So this is equation number 1. Second scenario, when we see the same situation from frame of reference S dash, and this P point will be visualized somewhere here. Now we say this is not the P point, this is a P dash point. When we see from frame of reference S dash, its coordinates will be X dash, Y dash and Z dash, and this distance it will be CT dash on the same lines. So dashed coordinates are in S dash frame. Without dash coordinates they are in S frame. So same equation जब हम S dash frame में लिखेंगे, it will be X dash square, Y dash square, Z dash square, CT dash square. So these are the two equations. Here our frame of reference is moving, S dash frame move कर रहा है S frame के with respect में with a speed comparable to speed of light. So now we are to derive the connecting equations. हमें वो equations चाहिए जो S dash frame of reference एक inertial frame है, इसके coordinates को S frame जो कि एक और inertial frame है उसके coordinates से correlate करें, और उन equations को हम बोलते हैं Lorentz equations. So Lorentz equations में जब कोई frame move करता है with respect to a stationary frame S, तो जो फिजिक्स के लॉज हैं उनकी फॉर्म में कोई ज्यादा डिफरेंस नहीं आता है, वो सेम फॉर्म में रहते हैं. So all the physics laws, all the physical laws, they have same form in all inertial frames of references. तो जब हम कोरिलेट करते हैं S डैश के फ्रेम के कोऑर्डिनेट्स को S फ्रेम के कोऑर्डिनेट्स से, then we will get a linear relation between them. Only then all the laws they will be having same form, otherwise उनकी फॉर्म चेंज हो जाएगी. तो लीनियर रिलेशन हम सपोज करते हैं, लेट अस सपोज दोज रिलेशंस विल बी ऑफ द फॉर्म ऑफ x डैश इट इज इक्वल टू k is a constant x minus vt, because there is a motion along the x-axis, but there is no motion of frame of reference along y-axis and z-axis, so those relations will be simply like this. But as the Lorentz transformation equations, motion of the frame of reference affects space and time coordinates simultaneously, so time coordinates will be correlated like this. So these are the equations that we have supposed, and these equations they are connecting the coordinates of S dash frame with coordinates of S frame. So we mark these equations as 3, 4 and 5, and here K, M and N, these are constants whose values we are to determine. And finally when we find these values K, M and N, and substitute in these equations. These equations will be converted or termed as Lorentz transformation equations. So now we will substitute the value of x dash, y dash, z dash and t dash from equations 3, 4 and 5 into equation number 2. So we will be getting this. So now we will solve this. This term we take on the other side. This term we take on this side. So from this and this we will take k square minus c square n square common. Y square z square minus 2 vk square plus m n c square xt. It is equal to c square m square minus k square v square t square. We mark this as equation number 6. So comparing coefficients of equation number 1 and equation number 6. So equation number 1, x स्क्वायर का कोफिशिएंट 1 है, y स्क्वायर का कोफिशिएंट 1 है, z स्क्वायर का कोफिशिएंट 1 है, t स्क्वायर का कोफिशिएंट c स्क्वायर है. सो यहां से अगर हम कोफिशिएंट्स कंपेयर करें तो ये वाला कोफिशिएंट उस इक्वेशन में 1 है, सो इट विल बी k स्क्वायर, c स्क्वायर, n स्क्वायर, इट विल बी 1. ये वाली टर्म इक्वेशन नंबर 1 में नहीं है, सो दिस कोफिशिएंट इट विल बी v स्क्वायर प्लस m n c स्क्वायर, इट विल बी 0. ये वाला कोफिशिएंट t स्क्वायर का कोफिशिएंट है c स्क्वायर, so this term it will be c square m square, k square v square, it will be equal to c square. We mark this as 7, 8 and 9. So all our work will be solving these three equations. So now we try to solve these three equations. So multiply equation number 7 by v and subtract equation number 8. What we will be getting? So 7 नंबर को v से मल्टीप्लाई कर देंगे और 8 नंबर इक्वेशन सब्ट्रैक्ट कर देंगे. So it will be v minus 0. So it will be vk square, vc square n square, vk square mn c square is equal to v, and these two terms they will cancel out. So what we are with, these are two negative terms, इन दोनों को हम दूसरी साइड पे ले जाते हैं, यहाँ पे 0, so it will be v c square n square plus v plus m n c square. So c square n square plus 1 into v plus m n c square, it will be 0. तो इसको हम इक्वेशन नंबर 10 लिखते हैं. So now 7 and 8 के साथ हमने डील किया. Now we will be dealing with 7 and 9. So 7 and 9 के साथ डील करने के लिए हम 7 को v स्क्वायर से मल्टीप्लाई करेंगे एंड ऐड इक्वेशन नंबर 9. So multiply equation number 7 by v square and add equation number 9. So v square से जब हम मल्टीप्लाई करेंगे, it will be v square k square minus n square, v square k square minus c square n square, plus we have to add equation number 9, c square m square k square v square, c square m square, that is minus k square v square, और इसको जब हम v स्क्वायर से मल्टीप्लाई करेंगे, इट विल बी v स्क्वायर प्लस c स्क्वायर, so it will be v square plus c square. So now open the bracket, it will be v square k square minus v square c square n square, c square m square, k square v square plus c square. These two terms they will cancel out. So take all the terms on one side. It will be minus v square c square n square minus v square this term, c square m square minus c square, it is equal to 0. So minus v square, it is c square n square plus 1, c square m square minus 1, it is equal to 0. So mark this as equation number 11. So now we have two equations, equation number 10 and equation number 11. So now we will be dealing with these two. So we multiply equation number 10. Look at these two terms. Multiply equation number 10 by v and add equation number 11. So it will be c square n square plus 1 v square m n v c square minus v square c square n square plus 1 plus c square m square minus 1, it will be 0. So these two terms they will cancel out. So from here we will try to calculate the value of capital N. So it will be m n v c square m square minus c square is equal to 0. We can also cancel c in all the terms. It will be 1. So it will be m n v plus m square minus 1 is equal to 0. So m n v, it is equal to 1 minus m square. So n is equal to 1 minus m square upon mv. So we mark this as equation number 12. So now we substitute the value of n in equation number 10. So from 10 and 12. From 10 and 12. So equation number 10 is c square n square plus 1 plus v. C square n square plus 1 plus v. So it is c square 1 minus m square over mv, c square n square plus 1 into v. So this is the first term, c square n square plus 1 into v, mn c square. So it will be m n c square. It is equal to 0. So now we have to solve this equation and find the value of m. So this article is very important, but it contains a lot of mathematics. So be patient. धीरे धीरे सॉल्व करना है, गलती होने के चांस काफी ज्यादा है. So it will be c square v 1 minus m square upon mv plus v. So m cancel हो गया. c square by v 1 minus m square, it is equal to 0. So now we have to solve this. We take v as separate term and try to find the common out of these two. So it will be this term, it will be c square v 1 minus m square upon m square v square, c square by v 1 minus m square, it is equal to 0. This one v cancels out. C square by v 1 minus m square, this is common. So it will be 1 minus m square by m square plus 1. So when we deal with this, it will be c square by v 1 minus m square. We take LCM m square plus m square plus m square. It is equal to 0. So this term cancels out. So here we are left with 1 minus m square divided by m square. It is equal to 0. So this will be like c square by v 1 minus m square divided by m square, it is equal to minus v. So 1 minus m square upon m square, it will be minus v square by c square. So this we can write like this, 1 by m square minus 1 minus v square by c square. So 1 by m square, it will be minus 1 goes on other side, becomes plus 1. So m square. So take the LCM here. So m square, it will be c square upon c square minus v square. So it will be 1 over 1 minus v square by c square. So m, it will be plus minus 1 upon square root of 1 minus v square by c square. So first constant जो हमने कैलकुलेट करना था उसकी वैल्यू हमारे पास आ गई है and we represent it by equation number 13. Now we will find our next constant n. So for that we will be using equation 12. Substitute the value of m in equation number 12. So from 12 and 13, n is equal to, it is 1 minus m square over mv. So here we substitute the value of m square. So value of m square is this one, c square upon c square minus v square divided by mv. We neglect the negative sign. We take positive sign for further calculations. 1 over 1 minus v square upon c square into v. So when we solve this, this goes on the numerator, v remains here. Here it is c square minus v square. When we take the LCM, so one v cancels with this, so it is minus v upon c square minus v square. So we are to now simplify this. C square is common, minus v, so it is minus v upon c square, 1 upon, these will cancel out and it will be square root. This is n. So this is equation number 14. So as we have started with three constants, m, n and k, we obtained the value of m and n. So now we will find the value of k. So k is in equation, now we have to search the equation. There are so many equations. It is in 7th equation. Substitute the value of n in 7. So from 7, it is k square minus c square n square, it is 1. K square minus c square, it is minus n square. V upon c square, 1 minus v square upon c square whole square is equal to 1. So it is k square, c square, v square, c raised to power 4, 1 minus v square by c square, it is equal to 1. So it is k square, v square by c square, one minus v square by c square is equal to 1. K square, it is equal to 1 plus v square by c square, 1 minus v square by c square. Now we take the LCM. 1 minus v square by c square, 1 minus v square by c square plus v square by c square. These two terms cancel out. So k comes out to be plus minus 1 upon v square minus c square. Again we ignore the negative sign. We keep the positive sign only. We mark this as equation number 15. So substituting all these values in equation number 3, 4 and 5, we will get the various Lorentz transformation equations. So for Lorentz transformations from 3, 4 and 5, we will get x dash is equal to, so x dash we supposed in equation number 3 as k x minus vt. So k is this x minus vt k. So this is the first equation. Second equation is y dash is equal to y. Third equation is z dash is equal to z. Third equation is t dash. So t dash we supposed equal to mt plus nx. mt nx. mt plus nx. Value of m is 1 minus v square upon c square under root. So it is 1 over 1 minus v square upon c square plus n is where is n? N is there. Minus v upon c square 1 minus v square upon c square into x. So t dash it is equal to t minus vx upon c square divided by 1 minus v square upon c square. So these four equations are called set of Lorentz transformation equations. These three one, and this is the fourth one. So far, inverse Lorentz transformation equations. We change simply v to minus v and dashed quantities to without a dash. So x is equal to x dash minus v. Sign of v is to be changed. It will be x dash plus vt dash divided by 1 minus v square by c square. Y dash, y will be equal to y dash, z will be equal to z dash, t will be equal to t dash plus v x dash by c square 1 minus v square by c square. So these are the four inverse Lorentz transformation equations. So now we will have two special cases. First special case, if v is equal to 0, the frame of reference s dash is at rest, then the equations will be, if we substitute v is equal to 0, then equations will be like x dash is equal to x, y dash is equal to y, z dash is equal to z, t dash will be equal to t, and these will be the identity transformations. Second special case, if velocity with which the frame of reference s dash is moving is very smaller than speed of light, then v square upon c square can be neglected as compared to 1. So we can write 1 minus v square upon c square as 1. So here the equations will turn out to be, if this will be 1, so equations will be like x dash is equal to x minus vt, y dash is equal to y, z dash will be equal to z, t dash it will be, this term will be this term they will not be there, they will be ignored, neglected, so it will be like this. So these are our Galilean transformation equations. So what is our conclusion? That Lorentz transformation equations, they give us Galilean transformation equations when our frame of reference is moving with a velocity very small or negligible as compared to speed of light. Third case, if v is equal to c or v is greater than c in any of the cases, then Lorentz transformation equations gives unphysical or absurd results. So whenever we are to apply the Lorentz transformation equations, speed of the frame of reference S dash should be small as compared to speed of light, or it should be comparable to speed of light. Next part is show that using Lorentz transformations. Left hand side is x dash square c square t dash square. So x dash is x minus vt, 1 minus v square upon c square, t minus vx upon c square, so it is x minus vt square, 1 minus v square upon c square, t minus vx upon c square, 1 minus v square upon c square. So take the LCM. Square. So solve this. These two cancels out. From these two terms, take x square common. From these two terms, take c square t square common. This can be written as this cancels out. So this is equal to right hand side. Hence proved. So this completes today's lecture. Keep in touch for next lectures. Thanks a lot.